The signal source outputs a 1 VPP sine wave. But when connected to the oscilloscope, the reading doubles directly to 2 VPP. Could it be that the instrument is malfunctioning? Actually, the issue lies in impedance matching. When we connect the oscilloscope and the signal source, a closed circuit is formed. In this circuit, the signal source is equivalent to an ideal voltage source in series with a 50 ohms resistor. The oscilloscope serves as a load resistor connected in series with the internal resistance, typically set to two resistance values, 50 ohms and 1 megaohm, when the selected resistance is 50 ohms. According to the voltage division principle in series circuits, the internal resistance of the signal source will drop half of the output voltage when selecting 1 megaohm, according to the same principle. The voltage divided by the internal resistance of the signal source can be neglected. In practical applications, to minimize the impact of the signal source's internal resistance on the output waveform, it is necessary to set the channel impedance on the signal source. When the signal source impedance is set to 50 ohms, to eliminate the voltage dropped by the internal resistance, the signal source will actually output a 2 VPP signal. At this point, if the oscilloscope is set to 50 ohms impedance, the voltage is divided equally between the internal resistance, 50 ohms, and the load 50 ohms due to the voltage division effect, resulting in a displayed voltage of 1 volt on the oscilloscope. However, when the impedance on the oscilloscope is set to 1 megaohm, the voltage dropped by the signal source's internal resistance becomes negligible, and the oscilloscope almost captures the entire signal. In this case, the voltage displayed on the oscilloscope represents the actual output voltage of the signal source, which is 2 volts. Similarly, when the signal source impedance is set to 1 megaohm high impedance, when the oscilloscope's impedance is set to 50 ohms, the significant internal resistance difference causes the signal source's internal resistance to dissipate most of the voltage, resulting in only 0.5 volts being displayed on the oscilloscope. We can see that the impedance set by the signal source is 50 ohms, while the impedance configured on the oscilloscope is 1 megaohm. The mismatching impedance results in inconsistent amplitudes. Now set the impedance to 50 ohms. Now set the impedance to 50 ohms, and the measured peak-to-peak value will match the signal source. Therefore, to obtain accurate measurement results, it is essential to ensure that the output impedance of the signal source matches the input impedance of the oscilloscope.